events which were formative of the kinds of regulation that around the world we now face. The first was the 1974 Nipro UK Flixborough disaster. Has anybody not heard of that? Only one, two. Haven't heard of it? Right, well, you will have in a minute. Right, okay. Okay. It was serious. 28 people died. Between 30 and 50 were badly injured. There were loads of properties that were damaged, some of them flattened, others just busted roofs and windows. Very, very nasty. Right? Flixborough is in England, right on the banks, if you like, of the Trent River. And I'll show you the next where it is. Come on. I'm moving the wheel.
Well, press the left button then. Left side of the...
Come on, somebody else do the clever stuff. I'll talk, you do it. Oh yeah, and I haven't mentioned the other two events. I was employed at Goodrich Chemical Altona for 11 years. That is my longest ever employ, other than I.F. Thomas and Associates, which has been much longer than that. I got so fed up with not getting on with bosses that I formed myself, and I don't get fed up with myself. So there's Nipro there, there's Goodrich next, there's terminals at Coode Island next, and what's it doing now?
I'll do it for you.
Yeah, okay. Well, this is Nipro in Flixborough. The plant was jointly built and owned by Dutch State Mines and the National Coal Board, with a little bit of interest still from Fisons. Next one. Right, the problem was that there was a train of 6 reactors that reacted at high temperature, high pressure to convert cyclohexane into cyclohexanol and we'll see in a minute. And one of them, which now stands there, that's the one that was taken out of service because it developed a bloody great big crack. All right? So that means we've got 1, 2, 3, 4, nothing, 6. And instead of daring to shut down, the absolute priority for them was to keep going. So they ran a pipe across between numbers 4 and 6 and kept going. All right, next one. That's just to give you an idea of what happened. It's not a particularly good photo, but just to show how bad it was. That's long after the event, after the main event, with major explosions. It was a big vapor cloud explosion. You don't usually get someone right at that moment. Okay, so it was a serious vapor cloud explosion. That's one of the best photographs. That's a fire brigade photograph, again showing the 1, 2, 3, 4, 5, and the one in front, which was actually number 5. The thinking there was that given that one, or the thinking now, given that one was so seriously damaged, the plant should be shut down. We understand what the damage is and what it was caused by. We check all of the others, and then maybe we start up again. Oh no, they installed a temporary pipe and kept going. Next one. Just to tell you a little bit about what they were doing, and because I'm a chemical engineer, I think the only chemical engineer in the room, yes, no, I have to put a bit of chemistry in to prove what I am. Cyclohexane was converted using air and a catalyst at 155 degrees centigrade and 125 psi into cyclohexanone and cyclohexanol, so the alcohol and the ketone. All right? So that was the first stage. Cyclohexane is extremely reactive. Without an inhibitor, it will polymerize, produce massive heat and do lots and lots of damage. So it is a very dangerous process. Very dangerous even to consider, and yet the whole plant did it. Section 25A it was called. Then when you've got that mixture, you separate the mixture first. Cyclohexanone is what you want. The rest you would put back, recycle through the first process that I've just told you about. That then is converted chemically to cyclohexanone oxime, and then also on the same site to caprolactam. It's then sent elsewhere to form the polymer, polycaprolactam, which is nylon 6. Okay?
Is that the end product?
Yeah. So there's the structural formula, just to give you an idea. The six-membered ring is like, we call it a benzene ring. Okay? One O group to make the ketone, an NOH group to make the oxime. Now it's a 1, 2, 3, 4, 5, 6, 7-membered ring with an O and an NH caprolactam. And then we all know what a polymer is. It is an infinite number of molecules of that substance that join together at one of the joints and make a big long string. And that's, nowadays, that's the problem. Plastics are the problem nowadays, as you know. Now, what I've written there is a brief summary of what caused this massive explosion. Catastrophic failure of a temporary pipe between reactors 4 and 6, which I mentioned before, when reactor 5 was removed. Originally, the word wrong said bullshit, right? That is crap. That's the official finding. It took them months and months at the Court of Inquiry, Her Majesty's blooming something, goodness knows what, and they got it wrong. But that's my opinion. I'm not saying that as a fact. What I say happened, in the reaction, they often ended up with what they called black Ka, black ketone alcohol. Ketone alcohol is the two, the cyclohexanone and the cyclohexanol. Black, burnt. That was bad news, right? So they regularly got burnt product in the process. What happens if you put oxygen in with something that is extremely active at a high pressure, high temperature? It burns. If it burns severely, boom, okay? So there was, in my view, an explosion inside the reactor, probably in number 4. Not sure, but probably anywhere it would have done the same thing. So we have an internal reaction, very serious indeed. Now, even more serious in occupational health and safety terms, look at that third sentence. An oxygen sensor was disabled on purpose because they had run out of nitrogen. If the oxygen sensor says there is not enough oxygen, or there is too much oxygen present, 4% was what they thought, 4% oxygen. If there's too much, nitrogen gets injected automatically to make sure the system stays safe. They deactivated that oxygen sensor. Doesn't need much to know what happened next then, does it? So the oxygen level...
The injection of nitrogen is the control one.
Yes, the injection of nitrogen. Obviously air is a mixture of oxygen and nitrogen.
Plant when you haven't got nitrogen.
Exactly, but they were just approaching a weekend.
Yeah,
And
well,
they were going to run it across that weekend regardless.
Why do people put 6-inch nails
Into their what?
Because they haven't got copper nails.
in?
What level
Jonathan.
of person made the decision?
I've no idea. I've no idea. In fact, you wouldn't believe it. I shouldn't tell you this. I know that it's a fact because I studied that accident in great detail quite a few years ago now. Went over there, met Dr. Keith Googan, who was the expert used by the inquiry, spent several nights with him, several days up the pub and all sorts. Great bloke. Why did I say that?
Because you were going to say who made the decision.
Ah, yeah, right. So, despite all of that, I now cannot find, you don't write this down, please. I cannot find the reference that says that the oxygen sensor was rendered inactive because they wanted to run over the weekend. I know it exists, but I haven't found it yet. I've got that much information on
That would be in a committee of inquiry.
Not as far as I've... Oh, God, no. The actual formal inquiry is just not exactly a total whitewash, but it is a whitewash. I'll explain that in a minute. Yeah. Jeff?
So you believe the primary explosion occurred in reactor 4?
Inside one of the reactors, probably number 4.
So the plant, and so that then precipitated everything blowing up, did it? Or was it also...
Yes.
All the damage was just...
You imagine if all 6 reactors are properly joined together and one of them gets an explosion in it, it's going to create chaos. In this case, because there was this temporary pipe between numbers 4 and 6, what the explosion did was blow that pipe off. It did that to the pipe first, absolutely flattened it, and then dropped it to the ground. So I'll move on because it's all there. It's all there somewhere. Next one, please. David?
Stop. Page the next one.
Oh, yeah, consequently, black Ka, which is black ketone alcohol formed, burnt ketone alcohol. Then it found the weakest point in the 6 reactor train, which was the 4-5 temporary pipe, which I'll show you in a minute. And my view is that if all 6 reactors were present, it might have been a lot worse, getting an explosion inside of...
But you said the pipe was flattened. That sounds like an import.
Oh, I'll show you in a minute and then you'll see. Next one, please. David? Yeah, okay. Next one, yeah. Oh, there's an awful lot in total.
Sorry, I didn't like me interrupting you.
You're good, Dave?
Yep, done.
That's the next one, is it? Right, this is just to show, there it is. Reactors 1, 2, 3, 4, fed from one to the next by gravity through these bellows units, okay? 20, 24, 28, 28-inch bellows units, I think they were. And then where number 5 is taken out, there was this bypass pipe. That's all you need to know from that diagram. Next one, please. There it is. Now, the official inquiry spent most of its time and pages on talking about that pipe. They say the pipe failed, not that there was an explosion inside the reactors. They say that it failed because it wasn't properly supported, because it wasn't properly designed, because it was bouncing sideways, bouncing up and down. I'm not saying that's bull dust, not that, but I don't think that's what happened. Next one, please, David. Back one, there. Now, if you look and see that pipe, it only had to drop from about the ceiling level to the ground. It would not have ended up shaped like that if it was just by falling. Next one then. We have been to Flixborough a total of 3 times. The first time was intense with Dr. Googan. who, if anybody knows where he is, I want to know, because I've not been able to locate him currently. He might even have died. I hope not, because he's only a little bit older than me. We went there again, and that's us at the village, Joan and I at the village hall. Some of you know Joan, she'll be here later. Next one. And then, back one, then at the local pub, of course. So on.
Typical investigation process.
Of course, my God. Especially with Guinness, like tonight.
Disinfectant quality alcohol.
Strong investigative method.
So that was that. Now, at another visit, at the 50th anniversary, this is the North Lincolnshire Museum, which is in Scunthorpe in Lincolnshire. They devoted the whole time or months, to an exhibition concerning the Blixborough disaster. We weren't at the actual 50th anniversary because obviously they all met at the site. We weren't over there then, but shortly afterwards. So you all saw that last one, all right? Yeah. The next one, chap on the left, he's only just poking his nose in there. That is Muhammad Ali, who is a chemical engineer, retired, who worked as the safety engineer at the petrochemical refinery. What's the river? The Humber. The Humber River petroleum refinery. So he knew his stuff. We met him too. We stayed with him too. And we went to the museum together. And there's the front of it. Now, next one. That is, guess who? With his jacket on. With two people who were the firefighters at the time. And I have in my possession a book, quite thick, called I Was There, written by one of the fire people. Oh, is time going all right? I haven't got the next subject yet, but I forgot to bring it. Right, Goodrich, Altona. In Altona, there were seven companies. Feedstock came from the mobile Altona refinery and went boom, 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 boom along the line of all of the seven companies. Goodrich was one of those seven. It manufactured PVC from the feedstock to Goodrich was ethylene dichloride, EDC, which was processed in a furnace into vinyl chloride, and then that was polymerized in a series of reactors on site. And I've been inside one. The funny feeling being inside something as pressure vessel like that, cleaning it out, you know. That was when there was a strike, when the workers had refused to go in, so the posses went in instead. Was that the next one? Yeah, it was the next one, right. This is the morning after the accident, and the accident comprised the opening of the bottom valve of that Horton sphere, 700-ton Horton sphere at high pressure, can't remember the actual pressure, liquefied vinyl chloride. The valve was opened, I'll show you how in a minute, and whoosh, 676 tons escaped to atmosphere, making a massive vapour cloud. And if it had gone boom, I wouldn't be talking to you, of course. It didn't. It was dispersed. And this is something that also needs to be understood. There was only a gentle breeze. The gentle breeze happened to be to the north, across a load of fields. Dispersed it without danger. The only danger would have been close. But close to, everything electric was shut down. Neighbouring plants were shut down, the roads were closed, the police wanted us all out. Me, even though I had a responsibility, wouldn't let me back, and so on and so on. Next one, please. This is the pipe in question. This is the bottom valve. Kitt's 100mm ball valve. A lot of you will know what that is. Takes quite a force to move it. This assembly, with its pneumatic actuating cylinder, weighed about 8 kilograms. The official explanation, and there is no other explanation, is that was left hanging on the valve, and then they all went to lunch. And while they were all at lunch, the valve gradually pulled the valve open. To open the valve, you need 90 kilograms. 90. So it wasn't that. Also, they're showing those two U-bolts that clamp the bottom end of the pneumatic actuator there. It wasn't there, it was up there. They're just doing things to make it look more likely that their theory is the correct one. Next then.
Is there a double block and bleed on this? I mean, that's basic of any relief area in atmosphere.
That's not a relief, that's a...
I mean, you're saying it just comes out and there was just one valve for it to go into atmosphere, nothing else there?
No.
Well, since I was a kid back in the 60s, that hasn't been acceptable on any point. Okay.
That's the input. Have we got... No, back to it if you could, David. Back to it. Down. It's going right back up again. Right. But the next one. Yeah, next one.
How was it?
Oh, come on. There we are. That's the next one. This is the pipe which was, can you see the bend there, down there, and then another bend, and there's the flange, right? That flange was connected to the bottom valve of the Horton sphere. It's resting on the ground. My belief, and of course we don't know the facts, Goodrich was very careful at making sure that nobody knew anything. Show me next one, please. That's me, a lot younger. Beard, black, not white. Pointing to the U-bolts, and you can see where the U-bolts were mounted there and there. What they did was to undo the flange to get that pipe off, to take it away and replace it. They undid the flange first, in my view. It was heavy, it dropped straight down, pulled the valve wide open. The company says that it was the weight of it hanging there. They say that the valve was only cracked open. It was wide open. Okay, next one.
It fell down during the process of disconnecting.
Yeah.
There were workers.
Yeah, and of course you can't lift that back up easily. And of course, great mass of vinyl chloride.
But under that scenario, they knew what was going on.
Yeah,
So
yeah.
they had just one barrier between them and the active liquid.
Yeah, the vapor.
That hasn't been allowed since the 30s, probably, in any design.
So that's a good point. It is a good point. But the other problem, and David, you'll like this, the maintenance people wrote a normal maintenance work order. They didn't see the need for a hazardous work permit. If they had done, it would have brought in the safety people, possibly even me. All right, next one. Because we do have to keep going. We're not there yet. So looking at the chemistry again, vinyl chloride monomer, C2H3Cl, produced from ethylene dichloride, C2H4Cl2, in a furnace. So that was a dangerous process, and there was another accident there which I won't tell you about tonight. Polymerizing vinyl chloride produces polyvinyl chloride, and ethylene dichloride, EDC, was manufactured at one of the other plants in the Altona petrochemical complex. And the next one. Facts of the matter never came to light A minor breach of environmental rules, which could have cost $10,000 or something, they charged them $2,000.
Cost of a new
It
bill.
was a lot of money in those days.
Oh, was it hell? Was it hell? The company is now gone, but all of the Altona petrochemical companies have now gone. Quenos was the last to survive, and that closed late last year. And the whole of the land has been sold to a property developer.
Viva's still going.
What?
Viva's still going down there, isn't it?
Oh, Viva's in Geelong. Yes, that's still going. That's Geelong, not here.
Why are they closed here?
Who said that?
Why are they closed?
Must be, well, it's economics. It must be because making stuff in China is cheap. The whole plant was owned by, not that plant, but the Quenos, which was the last company to survive, was 100% owned by the National China Chemical Corporation. Now, next one, last one. How's my time? Where is he, Pete?
No, you're on.
Right, Coode Island fires. We all know about that, don't we? Yeah? Yeah, good. This is a view of Coode Island looking from the south with the Maribyrnong River on the, the left side, if you like, going away. And this just says basically what was involved. Tank 80 contained vinyl cyanide, which is acrylonitrile in common parlance. Hello, John. I wondered where he'd gone. Tank 81, which was near to it, contained phenol. The truck there was a truck being filled with benzene at the time. And this whole business, massive vapour cloud, massive explosion. On the following day, because they were not able to put out a fire on a flange on the methyl ethyl ketone, MEK, tank, that went boom as well. So that's why the Coode Island fires, why the word fires is plural, right? Because it lasted 2 days. Yep, go. Just a picture to show, again, you don't get pictures when it's actually happening. That's just a little bit later, but it was massive. Okay, next. Vapor cloud explosion comprising acrylonitrile, which is also known as vinyl cyanide, there's its formula, being transferred from ship into tank 80. Even that is disputed. Some say it wasn't being transferred at the time. And the official cause was St Elmo's fire. You know what St Elmo's fire is? It's like static lightning that makes a glow around masts of ships and things like that. It's not that common. Igniting leakage of acrylonitrile vapour from the tank top pressure vacuum relief valve, which I'll show you in a minute. Not necessarily wrong, just I don't bloody believe it. Not at all. So there's the word wrong again. Not caused by this very rare phenomenon. Evidence which was not put, and there was a lot of evidence not put, a lot of people were not called, shows that the conclusion should have been cause unknown. The coroner, Jacinta Heffy, the coroner presiding over the inquest, considered suing me because of my report. That report is in a book which I intended to bring and forgot. The Fire Brigade book for the Flixborough disaster, the 50th anniversary. I intended to bring that, I forgot. But I'm not perfect. Right, next one. This is the top of tank 80. The thicker, darker lines are the cast alloy pressure vacuum valve assembly. Not like a closed valve, completely closed, with a pressure pallet and a vacuum pallet, weights, heavy weights, circular heavy weights that were moved up or down to relieve pressure or to relieve vacuum, okay? A modification was made subsequently because of the environmental regulations. A vapor recovery system was attached. And that's the thin stuff, just thin sheet metal, not able to keep it pressure tight or leak tight, through here and onto the vapor recovery system. Okay, next one. Now, this is interesting. For me, it's particularly interesting. I spent every day of a month at the inquest, which didn't earn anything, so, you know, very honourable bloke, you see. This is the duplex flow diverter box, the beginning of the recovery system. These two pieces here, shown better on there, were inside there. I was given permission to go up and photograph those parts during an interval, lunch break I think it was, and I found those two items inside the box. The court didn't know about them before then. So go back to the previous diagram a minute. So one of the guide pins, can you see the name guide pin, was either cut off or broken off. See the guide tube up above there? That was sawn off. The question is, was that done before the event or after? We don't know. The other claim made by others who weren't called was that the pressure pallet, which is a lead weight, was always taken out when they'd got ship-to-shore transfer going because it saved 4 or 5 hours. All right? In this case, because it was, implicated in the accident, it is alleged that that pressure pallet was chucked in the river. None of us know. Right, next one again. And
So
then
they take the lead, the weight out, but the valve is not working.
yeah, so it's open, so that
allow things to fill up easily.
So that the tank fills more easily and the vapor, bugger the vapor, Yeah. Right, next one. Right, now I don't expect anybody to read this, me included. There are 2 pages. I listed here 16 possible other causes. Just go back, there we are, in my report, which is in the book that I forgot to bring, but you're all welcome to see it if you wish. There were 42 other possible causes. Okay, next. Yep. Now, this is the plant, as was. The tank number 80 with the red diagonals up there was the acrylonitrile tank. 81, can we see? Yeah, 81's next to it. That was the phenol tank. 80 in the event, it's alleged that the fire started at ground level. We don't know that for sure. Welding spark, problem with the benzene in the loading gantry, the truck loading gantry, all sorts of possibilities. Even someone disconnecting the wrong pipe, because there's lots of pipes that go to different tanks. We don't know. But tank 80 was lifted up into the air and crashed back down. That's how bad the explosion was. Tank 81 phenol did the same. Several other tanks, their lids blew off and the product was burnt. So now, just to show you some more pictures. Is that the next one? Right, it is. I wanted to show you some close-ups. I don't think I did many close-ups, but yeah, there's one. But go back a minute. They are Department of Minerals and Energy officials. That one and that one. All right. He's a worker, I'm not sure who he was. I probably knew at the time. This is Dennis Wadeson, the plant manager at Terminals. He gave me a lot of information that was also not called, and he was not called, that helped to make us understand that it wasn't bloody St Elmo's fire, all right, that it was something else. Okay, next one. Yeah, just a local shot. That one's important because tank 63, I'm not sure what that contained at the moment, probably MEK or something, that is on the neighbouring Mobil site. So the lid blew off and landed on a different company site. I think that's all. Try. Oh, a bit of fun. Would you like to see a bit of fun?
Can we just go back and ask you some questions about what you
Yes,
presented?
let's.
Oh, please, before the bit of fun.
Can
Right.
I just ask the Flixborough, you said it wasn't the pipe that went from bypass to the fifth vessel and the pipe was blown by the failure analysis. What was your assumption then? If it wasn't that, what actually caused the failure?
The explosion inside the plant.
And what caused the explosion? Because you said it's not what the commission found, which was the pipe.
The pipe hadn't been properly, yeah.
You're saying it's something else. What is that something else?
In a dangerous reaction like that, where cyclohexane is extremely reactive, reacting on purpose with oxygen in the air is a very dangerous process. At pressure, at high temperature, high pressure, that's why there was an oxygen sensor.
Spontaneous combustion.
Yeah, oxygen was not allowed to be higher than 4%. 4% is still enough to make the reaction take place. But any more than that, and problems could arise, like black product, as we said, or in my case, and I know this because the chemistry is such that it is most likely that an explosion occurred inside the reactor.
So you're saying that the pipe failure, which could have let oxygen in, wasn't the cause, but something else
Was a consequence.
they didn't come across was the cause. So how come it's gone this far without an actual cause being agreed upon?
They didn't want. They
That
didn't.
seems to be the theme of the presentation. The standard of,
Sorry, it's just not making sense.
well, the standard of forensic investigation, again, is the same in each of these examples. The standard of the forensic investigation and subsequent official inquiries were simply not adequate.
In all three cases, that's correct.
But they
Yeah.
came to the pipe failure, which could have let the oxygen in and caused the explosion. And that's what they came to.
That's what they believe.
That was probably the easy answer than blaming somebody for actually making decisions.
The
Oxygen sensor.
the temp.
Nitrogen on the site to control it.
Right, Mark, you're not wrong. The temporary pipe, dogleg pipe as it was drawn by the maintenance people in chalk on the workshop floor. They used pipe that they'd got handy. They know how to weld. They welded it up nicely. And the 20-inch pipe then joined to the 28-inch bellows unit at each end, expansion bellows unit, right? And scaffold with wooden planks designed to hold it. They say, and it's easy to say, if it had been properly designed by engineers, it wouldn't have failed. But they're also saying, and tests that were done afterwards on this pipe assembly, on a pipe assembly like it, two completely independent tests at different research establishments, neither of them could make the pipe fail in the way that it did. It squashed it and bent it, pulled the bellows apart, small hole in the bellows first, but none of this, what we call jackknifing, that resulted in the picture of it.
I mean, the bending and everything goes to that pipe looks like it's a victim of an explosion.
Yeah, and it's ironic too, because if there wasn't a temporary pipe in there, temporary pipe, when the force of explosion was coming at it, would have failed quite easily. If it wasn't there, if the reactor was there instead and they'd had an explosion inside it rather than just burning, God help us. Jeffrey.
So your theory of this, Ian, is that reactor 4 exploded, and that then caused all the other reactors to explode with it.
You just get a check.
Well, yes and no, but
Well,
somewhere.
my question is not so much about the failure. I want to know is,
Mhm.
could it have been designed? Should it have been designed? Are they designed now such that if you get an isolated failure in one unit, it doesn't then take out everything else as well?
No, they were all interconnected just by gravity flow.
So there's
No
no way
way
we
would
could
you get something to prevent chain reaction.
Yeah, which was the oxygen sensor.
No. Now,
Yeah.
in a design of today's,
Oh, yes. Oh, yes. But in addition, and I'm not certain of this, the air oxidation process is not used anymore. When they need to make nylon 6, they use a completely different chemical pathway, which I've not presented a slide on. Yep.
Sorry, you're producing here a whole lot of questions like the next one where the pipe failed, which didn't comply with any of the standards, whether it be Australian 1210 or the BS 5500 British standards,
The
design of pressure vessels.
the temporary
You're
pipe.
saying they've been bypassed, and you're not blaming the bypassing of the engineering as causing these as being
No, because that's what they did. They said it was not properly designed. It was not, no engineers were involved in designing it or constructing it. Just to
So it
make,
wasn't designed to British BS 5500.
wouldn't have been designed to any standard. But David, subsequent tests were done that showed that the pipe assembly that was fully compliant with standards and with engineers' requirements.
the standard, just because it complies with the standard, it doesn't mean it's fit for purpose.
But he's giving us examples of things that are not allowed in the standard.
Yeah.
So he's saying that
But even if it
the
wasn't-
standard was ignored.
Even if it was designed to the standard, would it not, it doesn't mean just because it's not designed to the standard that it fails. And
That's right.
That's a
That's right.
misconception. You assume that because it's designed to a standard, it won't fail.
But
That's
if
not
it wasn't designed to the standard and failed, it seems to be in the two cases, the first two cases, then surely that is, I'm into pressure vessels and that's everything I do at the moment.
I agree that if it
And that's
means it's
just
less likely
unbelievable.
to fail, but it doesn't mean it won't.
And in this case, they say, and the authorities say, not just into Heffy, the coroner, the authorities say that the pipe as it was built was compliant. The right thickness, the right design.
With the safety procedure,
Yeah.
safety release.
Yeah, with the safety requirements. Yeah.
So although it wasn't designed specifically in line with the standard, when they actually looked at it afterwards, it would have actually met the standard.
Yes.
Can I-
Exactly, Mark. Yeah.
A different question.
Kelvin.
Yeah.
And then,
I also get used to the human factors piece. Right. The sensor was overridden because of the shortage of the nitrogen.
Yep.
For the weekend.
Yep.
I get really interested as to why that made sense to somebody to make that decision. So,
And that would have been plant manager level.
yeah, so the really interesting piece is that that's a really critical, but I think this whole thing comes back to that point. So I really want to understand, someone's intentionally made this decision with a hazardous waste. How did that come about and what drove that decision?
And how many people have you seen that said they didn't do something? You can clearly show that they've done.
That's not the
Because
question.
that man's got a lot to play.
Well, let me answer the question.
Let him answer the question.
Just put the question again.
So I'm really,
Kelvin?
I get interested in people make active decisions in the space for
Mhm,
lots of reasons. It does make sense to us, if that shouldn't have happened. I get interested as to why did they make the decision? What drove that
Right,
decision?
okay. Because they put production first. They weren't prepared to shut the plant down and not have it running over the weekend.
Yeah, so that's,
And the same with reactor 5 that was pulled out. Rather than checking why it had split and what the problems were, checking the other reactors, they kept it, the priority was to keep it going.
yeah, so So that goes to the crux of the problem, because you've got someone actively overriding a really critical safety control.
Yes, yes, absolutely. And I think you won't find that written in too many other places, but that's absolutely right. At the museum, at the Scunthorpe Museum, my paper that recommends that makes that point, is there in abbreviated form. And it's also in the fire brigade section of that exhibition. That's all I can do. I can only form my view and present it like now as best I can.
Yeah.
The other gentleman was before Patrick. Yeah, sorry, Jordan, not Jordan.
Yeah, Jordan.
Yeah, Jordan. Yeah.
I was asked on this last one that you presented here, you came up, like more so from a forensic point of view, you came up with 42 alternative
Yes, yes, yes.
What was the general reaction to your report by everyone from that? Like, was it
Right, the workers, absolutely. The workers say it was somebody welding that shouldn't have been. And the ground floor fire, spark, caused fire of something, and then reached the top of the tank, got into the tank, boom. Yeah. We don't know that, but that's the main popular theory of the workforce, and I don't blame them.
Did the theory get put to the coroner?
No, that wasn't put. None of the 42 were put.
I mean, 42 does seem an awful lot.
Right, let me explain it. There is another way of explaining it. When you get the coroner's report, the coroner's report contains 3 pages talking about other possibilities. 3 pages talking about, I can't remember, something else, and 11 pages talking about St Elmo's fire. Of course it was St Elmo's fire. If we find that, and all sorts of talking goes on ahead, if you don't watch Deed, what's it called, the program, Deed? Judge John Deed, if you don't watch, you must. All sorts of things go on behind the scenes. Yeah. They found St Elmo's fire as the cause because, in my view, what's the word? It involved, it blamed almost nobody else. Just a worker, was it? Yeah, chucking the pallet out or whatever.
Patrick.
Sorry, Patrick, yeah.
Now this is a bit off the wall, but there has been speculation that it was sabotage. So I'm about to ask you whether you think there's any evidence of sabotage. You talk about technical causes not motivated. But in the other context, and this is just from a purely speculative public point of view, I recall there being a large number of gas leaks and fires around the western suburbs up until then. They seem to be happening continually. This happened and then they stopped. No. Now, I don't know if that's correct. That's the impression I had from what I saw in the press. But you probably can't answer that question.
I can't. Sabotage. Oh, sabotage is possible. Of course it's possible. I mean, somebody could go up on top of the tank and chuck a burning rag down, and they wouldn't last if they did, but there are a lot of possibilities. Not
plausible. I mean, there was even a suggestion that it was linked to the John Friedrich National Safety Council conspiracy.
Oh, yeah.
Short out, 43.
I think that would just have been to say, we think it might be sabotage, just a way of avoiding the issue. The importance with things like this is that the industry learns everything possible to be learned, and of course they haven't.
No.
They didn't.
Now, last question, which is mine.
Peter.
So there were 3 formal inquiries into these 3 incidents. What were the fundamental flaws for those formal inquiries? What did we learn from this process? How could these inquiries have been done better?
What I have said in writing is that the bigger the event, the less likely to be involved in the inquiry are those most likely to know what happened. You know, the workers and the immediate engineers and the plant manager. None of those were called. Because it was a big event, there is no doubt in my mind that it had to be found in a way that would incriminate the least people, the least company people, I should say. Absolutely.
So your thesis is that the legal process, that's what we're talking about here,
Yeah.
wasn't particularly interested in root cause.
Even beyond that, with something like this, you do not put a lawyer in charge. You put either a very capable chemical engineer, in this case, in charge of the investigation, assisted by a lawyer, or by a lawyer directly assisted by a consultant chemical engineer of some esteem. So that's another.
Did the coroner have an expert assisting this coronial inquest?
Don't think so, no.
Who was the coroner?
Jacinta Heffey, Heffey, and she threatened to sue me because of what I wrote, and I put her name in it. I should have just written it with nobody's name in it, shouldn't I? But she decided against it, fortunately.
Do you think this sort of inquiry process is
Mark.
improved since?
I can answer that two ways. I think someone at a recent asset management council meeting, after the meeting had finished and there was just formal chit-chat, said to me, we were pretty bloody good before all these stupid OHA safety, OHSA stuff came into being. We were pretty good. And I'm not saying
nothing happened.
I'm not saying that's an absolute statement, but directionally it's a point. It is now so complex. The Occupational Health and Safety Act and its components are so complex that I think we may not be as much better off as we ought to be.
Put that into context. An entrapment case I did, the steelworks I was doing it for, they were killing in the 70s, one a week. And by the 2020s, they probably want to be 10.
So the regulations did help in that instance. I'm not saying that. I'm not saying they. I'm not saying they don't help. But yeah.
Well, fascinating presentation, interesting, thought-provoking. What FESA is about.
And where's? Oh, there he is. John's was blooming interesting too, in a completely different way. Well done, John.
Well, thank you very much, Ian. Your presentation there was totally spectacular.
You liked it? Did you like it? Oh, shit.
Okay, thank you.